I'm Matt Geiser. I'm responsible for the product management of IBM's storage for data, AI, and high performance computing offerings. So basically everything that Doug was talking about, those use cases are from the products in the IBM storage portfolio. When we talk about this global data platform, and I'll tell you the framework that I'm meaning when I say global data platform, but to set it up, I want to start basically with a view of why are we in a situation where a solution like a global data platform for unstructured data is essential. It's a critical solution at the right time that customers and organizations really are looking for right now. First, let's talk about the evolution of unstructured file and object data. I think for those folks that have been around the storage industry for many years, they know that in the 90s, externally attached storage and storage area networks were how you got things done if you wanted to share storage. But you also know that was a very complex proposition. And having staff to manage that was difficult. And there was a company that was a first mover using file server technology, network appliance, now NetApp, said, hey, here's this great solution. I remember when they said 15 minutes and you'll be up and running. This was probably in 1999, 15 minutes and you'll be up and running. And sure enough, you were. And you could provision and work with the storage. That was really the advent of where file storage started to gain its traction and get market share. Okay. Think also of the other dynamic that was happening right around the turn of the century, which was the adoption of the internet. Y2K forced a massive infrastructure overhaul. And what does that mean? Well, there's now these websites, and it's not just text. We've got all these images and video and various other content that's driving this exponential data growth that we've seen in unstructured data. And especially as we've gone into, full digital streaming and all of those things, you imagine the size of the content that we have. Now, we think of it sometimes from an entertainment perspective, but also think in terms of medical imaging. What did a medical image look like size-wise 20 years ago? How big is that when you start to talk about the resolutions that are available today? So that was one dynamic that really drove the adoption of file storage. Of course, I mentioned the internet. And as we started to see this concept, you remember when we were talking about this was the dream back in the late 80s and the early 90s. I don't want to have to build a data center. I want to outsource it somehow. Well, it started to become a reality with the internet pervasiveness, and we see it now today. The public cloud is now a very viable option for IT infrastructure. Well, the storage demands in that environment necessitated a new way to think about unstructured data. And that really was the sweet spot of a use case for object storage. You started to think about some of the static content. As you start to think about how that evolved over time, maybe it's a good backup solution or an archive solution or a retention solution if we're doing it on-prem or in the cloud. Well, this isn't I guess it wouldn't be your father's or your mother's object storage, it would be your older brother's object storage. Now, today, object storage is being used, for example, as the modern data lake. So let's not do Hadoop. Let's actually do object storage for my data lake repository. Now, Doug alluded to this point, this bit of Forbes research from a few years ago. If you think about all these point solutions for unstructured data that have come up and all the different companies, including IBM, that have been selling point solutions, customers say time and time again, I have data silos in my environment, right? These data silos are a big, big challenge. And you say, well, by themselves, we'll just figure out another platform solution for it, like a global data platform. Well, yeah, that is the answer. But there's two other dynamics are really driving the need for it now. One, I mentioned this, customers have IT infrastructure choices. So if you look at the bottom of this chart, edge and remote sites and traditional data centers have been with us since we first started computing. This concept of the public cloud, now customers have a choice where they put that, but that also creates further silos and geographical issues that need to be overcome. That's a challenge in and of itself. Add that to the rate and pace of application development, not just your old school app development. We're talking about data hungry apps, especially when you get into big data analytics, machine learning, and AI. All of a sudden, let's say I'm a research scientist and I'm trying to figure out something around wildfires, right? And I need to figure out how do wildfires start? Can I look at video footage and see wildfires starting? Well, how do I find that? Where is it, right? And so that's a very, very difficult challenge. Add to that, as the app developer and the data scientists that are associated with it, your boss came in and said, you need to turn it around in a matter of days, no more than a week. So for app development, we're no longer afforded the luxury as application developers of having years to develop an application. We got to turn it around. So the rate and pace of application development, coupled with the diverse IT infrastructure options that organizations have in front of them today, I think of it this way. We come up with a solution for this. The data fabric is really what the analysts are putting out there and what organizations are trying to deploy to deal with this. When it comes to data fabric solutions, they are very, very strong on the structured side of things, the database side of things. Rob Thomas, who's now one of our senior vice presidents at IBM, when he was leading the data and AI team for IBM, so it was probably 5 or 6 years ago, Rob used to say, there's no AI without IA. There's no artificial intelligence without an information architecture. I kind of like to say when I'm giving this pitch, in the same way, you can't really have a true end-to-end data fabric solution without a global data platform for your unstructured data. So what do I mean? I know that we've kind of led you on here for 30 minutes now between the different pitches. With what do we mean by a global data platform for unstructured data? It's a framework of data services. Data access services, how do the applications and workloads talk and find the data that they need and access the data they need to read it and to write it? The data caching and core services. Of course, the platform needs to have an engine, IBM Storage Scale as the engine of the global data platform. And then these caching services. How do I get the data to the right place at the right time, right? Think about the silos that we're talking about here and possibly the geography issues that we're talking about here. So those caching services are a key component of the framework. Data management services. Now, I think in a traditional IT service management perspective, visibility, control, and automation, right? VCA. How do I have visibility from that perspective down into my unstructured data, visibility to the data, and then how do this is essentially what was said earlier with respect to the critical nature of some of the unstructured data organizations have to their core business, to the things that they do. Control is a critical point. Governance is a critical point. And then the automation of that. And then lastly, data resiliency services. You do the first three and you're not secure, you don't have resiliency services, you kind of fall flat.
Question for you. You're talking about data fabric and you're talking about the entire this platform. And so IBM has the storage pieces of the puzzle for the data at rest pieces, right? And you have software that lets these pieces talk to each other and create this data fabric with the caching. But what are you guys doing for the interconnection between these pieces? Do you manage that interconnection or do you leave that to your end users and assume that they've done the work and know how that data is going to move from piece to piece and just rely on them to get that job done?
Yeah, so it's an excellent question. And there are some areas that you rely on having a network connection that's reliable, right? If the network connection goes down, I can't communicate and I can't do these things. We aren't deploying the network. We will certainly help architect and construct the network solution that's deployed. But in the general sense of a software-defined storage global data platform, we don't actually do the networking side of things.
Are you able to advise as far as to what that network's supposed to look like, given what kind of data motion is going to happen if you do X versus Y with caching or not caching?
In depth. In fact, and I don't know that Chris will talk directly to this, but in part of scoping out a solution, there's different entry points that you can have for this solution. So obviously, if you're just starting off with a high performance tiering scenario that I'll talk about in just a moment, that's going to look different than if you were trying to actually deploy the whole end-to-end global data platform to do everything.
Thank you.
Still trying to figure out what this is. I mean, is it scale and cost and Ceph, or is it scale only, or is it? What is it?
So the global data platform for unstructured data is a framework.
I understand framework, but I've got to understand what's behind the framework.
Yeah, the basis for the framework is many of these services are driven by storage scale. So you could do an end-to-end global data platform for unstructured data with just storage scale. However, I mentioned the concept of entry point. So if you think in terms of object storage, there may be an entry point where you want to modernize your data lake. You've got a bunch of old Hadoop infrastructure. You want to turn it into a modern data lake. We have solutions for that. That could be a Ceph-based solution. That could be a IBM Cloud Object Storage-based solution. Now, your activity and your entry point was to modernize the data lake. As you start to do that, if you say caching, for example, is an important piece, that introduces the next layer into the global data services framework.
And caching is provided by scale?
In this context, that is correct, yes.
So these layers are basically abstract design patterns that can be filled by multiple different products at IBM depending on the context.
Yeah, well, I would frame it this way. This is the framework for IBM's object and file storage solutions. IBM Storage Scale, IBM Storage Ceph, and IBM Cloud Object Storage.
Right, basically how they're all used, and this is how they're used and the problems they're solving and how they're going about it. But that box that's on the screen right now could be serviced by a different combination depending on the customer and their particular use case.
Yeah, I'll say in a hopefully a clarifying way, there are things like the data caching, which I'll cover in just a minute. It's based on a IBM Storage Scale technology called active file and object management. Mm-hmm. So if you want to leverage that data caching in core services in the constructs of this, you would have to deploy IBM Storage Scale.
Got it.
So let me go one by one through these because I do think it will add a little bit more clarity to some of the discussion about what it is. Starting with data access services. I think of this at a high level of what language does the workload or use case want to speak? If I'm a cloud native application that's been developed, I most likely will be speaking S3, object. If I am a high performance simulation workload, I might be speaking POSIX, high performance file. And so the first element that I talk about with the data access services is the global data platform must be multilingual. I need to speak all of the key protocols that the workloads and applications would speak. That's a good start, but it needs to be a shared multi-protocol approach. In other words, that cloud native or edge app might be speaking object and writing the data in object repositories. Later in the process, I may be doing something like a machine learning training and inferencing phase. I want the highest performance that I can get. And so I probably need to not only speak high performance NFS or POSIX, but I also need to be able to leverage GPU direct storage, GDS, right? So these data access services are a critical part, and it's shared multi-protocol access. So just to bring it back to some of the line of questioning that was happening, all of the solutions that I've mentioned, Scale, Ceph, Cloud Object Storage, can speak multiple protocols. In the shared multi-protocol access sense, that is a characteristic of the storage scale environment. And so again, in the spirit of deploying the solution, I'm looking for just a basic object storage solution. We have that.
So all of your data is presented through any one of these different interfaces?
In the case of IBM Storage Scale, it can be, yes.
Okay, so you can access, there could be a object that you could get both through NFS and as an S3 object.
That's correct.
Okay, and do you actually have a global namespace that's presented for each one of these? So anywhere that you access it throughout your global data access, it would have the same name?
That's correct.
Okay.
It's not creating copies of the data. It is the data. I'll talk a little bit more about what I think of the back end of this with the caching services next, but on the front end, if I'm accessing an object, a piece of data that was created and written into an object repository, if I then access that later via NFS, I'm not creating a new unique copy of it.
I'm trying to figure out what you're talking about as what the product actually does versus what you're talking about in the abstract. And so, okay, so that helps a lot. Thank you.
Yeah, sure. So moving on to data caching services. So this is the other side of the equation. And really, when I think of the caching services that are provided by IBM Storage Scale technology, I mentioned active file and object management. More than a decade ago, IBM Research created this capability for active file management. And over the past, I'll say 5 years, we've added object storage into this as well. So I think of these caching services two ways broadly. One is a vertical caching scenario. The other is a horizontal caching scenario. So in the vertical caching scenario, I think of this as I need to either virtualize existing file and object storage repositories. So I'm going to speak S3 to those underlying object repositories and NFS to those underlying file repositories and cache them. Not make an unnecessary copy of it, locally cache them to wherever the user is that needs to access that data. So practical example, many customers have NetApp deployed as their file storage. They may want to leverage that in a high performance way for, let's say, GPU direct storage. They're doing some inferencing on data, or they're doing training on large data sets, and they want to bring that into the high performance tier. They vertically cache that into the global data platform using IBM Storage Scale. Okay, now, two key parts. One, you get the benefit of that performance, but the other, you get the investment protection. Home stays home in this particular case. I have the cache locally here. Any data that gets updated in it gets updated down in the home, and then ultimately it can be decached from the global data platform, either automatically based on a policy or over time based on another policy. The other set, I mentioned horizontal caching scenarios. So when I think of these, I think I've got the remote and edge locations, I've got my core data center, and I have my public cloud. And a lot of these horizontal caching scenarios typically fall into sharing the data access across those different IT infrastructure options. So a hybrid cloud option. I want to do that high performance tiering scenario that I just talked about. Now let's say I want to use horizontal caching to do it because my data resides on-prem and I want to do it with compute that I'm going to provision and GPUs I'm going to provision just in time in the cloud. How do I burst that there? Well, again, the global data platform will do those through these hybrid cloud services. It will burst to the cloud, do whatever work you need to do on it, and then you can basically shut that infrastructure down once you're done. And the home, again, remains home on-prem. Collaboration services, doing things, one of the scenarios that we've talked about in many of our research institutions and hospitals and medical organizations is collaboration between the different hospitals or the different sites that they have. So how would you facilitate that? There's different locations. Again, home stays home. The medical equipment or the research equipment that's generated the data, that's where the data resides, but it can be cached to the edge or the remote locations that are using it. And then resiliency services in a very similar fashion, setting up either your active-active or your asynchronous types of relationships between the clusters and making sure that the data stays in sync and the home for that data remains home. Data management services. So this starts, I said earlier, visibility, control, and automation. So if you think in terms of visibility, getting visibility into all of the unstructured data, all of the file and object data in the environment is step one. Call it the data catalog, right? And basic metadata information is useful, but in many instances, you need to be able to customize the metadata tags, the data about the data, based on the industry, based on governance types of policies that may be from regulators, they may be from your organization itself, and so forth. That's the first step. And then ultimately, by implementing these approaches and having the data catalog there, the visibility into the global data platform for unstructured data, now you can get into the orchestration examples and the practical use cases for orchestrating when the data scientist and app developer comes to the IT team and says, I have a week to get all of the curbstones identified that have XYZ painted on them so we can go do a major infrastructure project, and I have a week to do that. Go get me all of that data. If you don't have that visibility, they have to tell you what data you're looking for. The IT folks need to go find it and then put that data in a place where the app developers and data scientists can work on it, and then they do the work. And how many times in that scenario do you think it works out that they get all the data right the first time? It's infrequent, as opposed
Matt,
to that. Yeah, go ahead.
Back to the data caching services slide. All these services that are potential solutions that you offer are all based on scale, I guess. Is it something that you configure as a professional services offering, or?
It can be done as a professional services offering, but it can also be done by the customer themselves. Yeah.
Or an IBM partner for that matter.
And geo-distributed collaboration, transparent sharing. So its presumption is that Scale is operating in multiple locations.
Correct.
And is caching some central repository of data across those locations.
Correct.
And it's read-write accessible to all those locations.
That's correct.
And yet there's still only a single copy of the data.
That's correct.
Someplace. Single, truthful.
The single source of truth. I said I was going to say the single source of truth because I've been accused of saying it too much. It's the single source of truth. Yes, that's correct.
For this. And it's just a feature of Scale?
It is, yeah. We've had many of the high performance computing customers, so some of our largest supercomputers leveraging this technology since it was introduced. It was introduced for that type of collaboration with the research labs and universities, and so it's been exercised very heavily over the past 15 years in that context.
In that environment, the single source would be the large lab, and then the researchers would be around the world accessing the data sitting in the lab? That's
one of the instances, yeah. So you think of like a particle accelerator or something like that. Right. They're storing all of the data there, and then the visitors that come in to do the experiments on it can then access the data that they have.
Globus used to have like multiple tier caching, cache level tier 1, tier 2, tier 3. All that's eliminated with Scale, is that?
It can be, but you can still also have different classes depending on what the requirement is.
So is this a distributed service, or is it actually a single Scale instance that takes care of this?
In the context of there's different implementations of Scale at the different sites, it's distributed. It's not a single instance. So the resiliency of Scale itself, if one of the nodes in the site goes down, there's other nodes that are out there to pick it up. And the same is true with respect to, the remote sites. That said, you would have to set up replication types of services if you wanted home to be recoverable if the home data did go down. Just picking up in the data management services, IBM Storage Scale also has a rich policy engine, basically for moving data across the different tiers of storage that it may have. So this may be more in the spirit of the tiering type of discussion, hierarchical storage management, information lifecycle management, and so forth. I've always said, though, one of the challenges in seeing mass adoption of effective or highly effective ILM has been the lack of visibility into data. And especially for storage administrators, that can be an extremely difficult thing. But once that visibility is there with the data catalog, all of a sudden the governance that can be applied to the policy engine, the retention, all of the different things that can be applied become very applicable and useful. in that context. So whether it's a regulation around privacy that's mandating that storage has to be stored somewhere for a certain period of time, or if it's with regard to cost efficiencies. All of those now, you get much greater visibility into the data sets, and policies can be defined by the organization to manage that. From a management perspective, we also do have tools for managing the resiliency and replication, the archiving, and those things, and they are an integrated part of the IBM Storage Scale offering. All right, data resiliency. This is the last one, and in this context, the fourth services framework or data services framework for the global data platform is resiliency. We think in terms of the NIST framework, so identify, protect, detect, respond, and recover. We do things like immutable snapshotting. We just introduced this capability, really leveraging the learning over the past 5 years that our mainframe storage and our flash system block storage teams have done around safeguarded copy. And we're calling our immutable snapshot capability the same thing. It's safeguarded copy. And by itself, it's interesting, but in a similar way to not having visibility to the data makes ILM only sort of interesting. It's the same way here if you don't have deep integration with the SIM tools. So if you look down on the detect area, Splunk, IBM QRadar, we have deep integration with those tools so that the SIM can actually tell IBM Storage Scale, hey, I see something suspicious, make a safeguarded copy. Now, once you have that safeguarded copy, and let's say it's a large scale environment, petabyte scale environment, and you determine the IT department determines it's a problem. I've got that safeguarded copy, and when it comes time to restore, petabyte scale environments and exabyte scale environments typically take a long time to restore. This is near instant data access. Because of the caching technology that I've talked about, it's near instant data access once you've identified the immutable snapshot that is appropriate and needs to be restored.
How do you do that?
Again, it's using the AFM, the caching technology, to basically say either on demand, get the data that the users are seeking in their environment while it's being restored into the environment, or you can even set up prefetch rules and say, you know what, look, this is the most important data. That's the stuff that I want populated into the new home drive first.
No, I mean, there's the other thing you said right after that was once you determine what is the good copies that you want to get of the data. So
yeah, you basically take and you promote the safeguarded copy snapshot to be the primary snapshot. Or it's not, I'm sorry, it's not a snapshot anymore in that particular case, to be the primary data set.
Okay.
So you're instantly mounting the safeguarded copy?
That's correct.
And whole data of that would be in the caching layer. I mean, like the copy could be spanning the cache as well as the actual storage beneath it. So
that's correct. Yes.
So how will it be instantaneous in that case then?
So from the perspective of instantaneous access, throughout the global data platform, if I need access to the data and it's not in my cache yet, AFM is going to bring it into the cache. It basically will prioritize. That's the bit that somebody's trying to get this data. I need this bit data brought into the primary environment now.
So from the user's perspective, it would look like some block accesses are fast while the others are slow because they are not in the cache. So the latency graph, if you plot it, will be up and down.
Yeah, depending on the size of the file or object that they're trying to access, there could be latency that they're dealing with.
This isn't block access, so the latencies are going to be higher anyway. You're not dealing. It is unstructured, right? It's unstructured data. Typically.
Yeah,
you're talking about subliminals.
These have latency overheads beyond what block. You know, the discussion we were having earlier.
You can instantly mount
an
exabyte of scale storage.
Yeah,
safeguard copy.
So essentially, yes, we have in Scale, we usually are dealing with millions, if not tens of millions. We test to hundreds of millions of files in terms of what we're actually trying to recover. We have worked with other customers in lab environments where they've done trillion file kind of testing as well. We don't really officially support the trillion file, but again, hundreds of million files we're very comfortable with.
But you're saying that you could instantly mount hundreds of millions of files that are sitting on a safeguarded copy. That's what he said.
Yep.
And you agree with that?
So, I mean, the mount doesn't need to be a heavyweight operation.
So if
It's safeguarded copy, it starts out being immutable, and they're mounting this data so that I can instantly access and start to modify it.
So are you familiar with when we used to have technology, again, I'll date myself, or ADSM, TSM, Spectrum Protect, we had an HSM technology back then, where you could do hierarchical storage management, and we used to have a feature in Scale, in GBFS, called Scale Out Backup and Recovery. You could basically capture your entire cluster, capture your metadata, capture your data, push it to a technology like tape at the time, and when you had disaster recovery, you would basically restore the cluster, restore the metadata, and you didn't necessarily have to pull all the data from tape. The users logged in, they basically saw their files, they opened it, it went and got to the library, pulled the tape, and pulled it here. This is the same concept, except now the backend is in an HSM kind of environment. It's a data caching services, as Matt's been talking about, that so happens to be a scale system, an object store kind of environment that we can sort of talk to and connect, and then bring that data back. So you have latency in bringing that data back because it's not living on the new environment. But yes, you can basically point to it, instant access to where you want to recover from.
So when you're talking about access, it's more about where you are mounting that mount point is aware of the metadata of the snapshot and not the data. As and when data is being referenced, that's when you pull it off and give it back, right?
That's correct. And you can see this, Windows Explorer has a way to kind of show this as well, to show like an offline mode. In Linux, right, you can do an ls command. I always do ls-l shirt for some reason. That's all the commands. It'll tell me what is resident and what is still remote. So you have you're going to see all the metadata. When you do the ls in that directory, I see all the data, right? The metadata is there. What I happen to cache, right, I can see as I pull it, the application opens, right? And then we automatically bring the blocks over you need, correct?
So you also defer bringing metadata, or metadata is by default brought in before mounting it.
Right. So I'm glad you asked that. We've actually been more sensitive because, as Matt has been talking about, if you connect to an object store that's in the cloud, that's over in Google and Amazon or Azure, maybe I got to be careful about the egress charges, right? So we actually have ways where you can tune it. In the past, you basically do an ls, all the metadata get pulled, right, and whatnot. We actually now have it where you can tag what metadata you want it to actually get pulled, what data you want to get pulled. So you can manually kind of turn the dial on what's the amount of data that I want to be shown immediately for restore or whatever I want to do. And then again, bringing that data in from that external point.
So this tagging is at the directory level, and you can tag it through the GUI?
Lifecycle management policies, correct.
Okay.
And you could do this across protocols, S3, object, S3, all the file protocols, NFS, SMB.
So the access layer that Matt's talked about, right? The SMB, the S3, CSI, GPU direct storage, that is, if I was running an NVIDIA app, it basically connecting to some data that doesn't happen to be there. It basically is going to do the open and just wait. You're going to do the wait, right? And I'll talk a little bit in my talk about data orchestration, how we can accelerate that. We've actually done this with technology. We had an IBM called LSF from Platform Computing, showed how LSF can plug in to Scale, to GBFS, and seamlessly move all that data. So that's before your job runs, you have all the data there.
And these tiers can also go back to even tape if you wanted to, I assume, right?
Exactly.
So you guys work with like Diamondback and things like that.
Yes.
Diamondback is very fun. You can modify common data. I mean, like you can modify data which is accessed by different protocols.
Correct.
Simultaneously.
Correct.
Like I can have a block protocol or a S3 protocol working and on a piece of object, and on the same time I can access the object as a file through NFS.
That's correct. We actually wrote a red paper about this probably in 2014. It was called Unified File and Object Access. It's actually a red paper we actually wrote. At the time, we did it with NFS, SMB, and POSIX. And we, at the time, our object interface was based on the OpenStack Swift protocol. So we showed how you can actually do this with file and object then. We've just continued to enhance that. HDFS came along, CSI, Container Storage Interface came along, GPU Direct Storage. We're accessing, the data via different protocols, and I should not silo the data to that particular protocol.
So how are customers using it, like in terms of cross-protocol coordination?
Like I said, we have customers in automotive space and life sciences space that are essentially, again, the workflow is sort of set up to maybe access one method with files, right? You're on your laptop right now, you see the data, you're there. And then over here, you may be kicking off an HPC job or a batch job that's sort of going to go use that. So, we're being cognizant of what's being shared, what's being locked. Is it read? Is it write? That's the intricate methods that Scale is sort of being able to keep it attached to in that environment.
So is that done at the caching level or at the management level?
It's done, I would say, probably more at the management level that Scale is sort of doing.
So do you have a distributed lock manager also, which actually does make sure that the consistency is not gone for a toss?
Yes, and again, I've been in this business for over 20 years, right? I worked on technology like things like PolyServe, right, where it had distributed lock managers. GPFS, when I first came on board to IBM, because I used to be at Compaq HP, like I said, DLM, distributed lock management, that's a very hard thing to do. And GPFS versions of 3 and version 4, right, they were working on that. Version 5 was a whole rewrite of this kind of environment, scaling out what we did for Oak Ridge National Labs in that environment. We really know how to do distributed lock management right. And byte range on a big file, right? So, yes.
And where does Ceph fits in the picture? Like I see Ceph and GPFS both being solving the same problem and kind of competitor with each other, but now you're bringing these two product lines into a unified platform. So where is it fitting compared to GPFS in that sense?
I'm glad you asked that question. I've actually been working with Matt here on the positioning of where Ceph is going to be and where Scale is going to be. And I spoke to a customer last week where they actually had this instance of, why do I need to use Ceph or why do I need to use Scale? And a lot of it really needs to be on the maturity of the workload that's operating. If I'm going to use GPU Direct Storage, a technology or, that's very high performance and access, well, that's going to be a Scale leaning method, right? If I need S3, object lock, versioning, all of the intricacies of S3, right? The Ceph community has done an outstanding job at maintaining the S3 compatibility in what Ceph is doing. So that's going to lean more Ceph. So is my workload hot, where I'm dealing with hot data all the time? Is my workload warm, or dealing with colder data? So you sort of think about that workload, and then again, bottom line, it comes to the workload, the time, the results that you have, and as we all know, the price.
Yeah. So more parallel and distributed workload would be good for GPFS, while more scale out, kind of not so high latency requirement would be, an object storage kind of would be better for Ceph. That's how the product provisioning is.
I think that's a good way to think about it. I think one of the other things I'd share with you, right, if you're familiar with the Hadoop story and how that's been changing over time, HDFS, Spark workloads, right? Spark workloads like, we do S3 now. We were doing Spark workloads on POSIX level kind of commands. I mean, nothing's going to beat POSIX Spark kind of workload as well. But there are some workloads where, maybe I don't want to use HDFS anymore. Maybe I'm going to use S3, Ceph S3A, or Cloud Object Storage could use that S3 interface for a Spark workload that's not high, throughput, many kind of operations that are going on. So yeah, you got to kind of think about that workload.
Great, thank you, Chris. So Doug mentioned, and I'll speed through these because I know I'm probably pressing over my time at this point, the restructuring of our IBM storage portfolio. So you've heard me slip a few times and say Spectrum Scale. We just announced this earlier this month, we're still in March. Just earlier this month, we announced the IBM Storage for Data and AI, IBM Storage Scale, IBM Ceph, and IBM Storage Scale System. Now, the IBM Storage Scale System is what I term as the quickest and fastest way, the simplest and fastest way to deploy a starting footprint for this global data platform for unstructured data concept. This is the current model was the Elastic Storage System 3500. We launched the performance model in May of last year and added the ability to attach hard disk drive enclosures to it. So you can have a fairly high density one rack solution. If you choose to do all performance, you can stack the two U24 NVMe units up in there, or you can mix it, have a hybrid solution, or you could do just a straight up hard disk drive capacity solution. This is something that is, where Spectrum Scale or GPFS as a project back 15, 20 years ago took months to deploy and get up and running. These systems can be up and running in an environment in less than a day. And so, again, if Chris and Doug have mentioned GPU direct storage, we see that if there's machine learning, AI types of use cases in the environment, this is one of the entry points that we see customers buying this performance model, the 2U24 NVMe model of storage scale system, and then getting started on it and using those benefits. Last chart here of content. We have a significant number of clients. The top organizations in the world in many industries are using IBM Storage Scale. So you can see we have over 6,000 clients worldwide. Many of the top auto manufacturers, banks, retailers, and so forth are using this solution in their environment. It was said earlier, these use cases are really what drove the concept of this global data platform for unstructured data. These are the problems that our customers are solving with this solution. And the analysts also, when you look over on the right, Gartner, IDC, for many years now, has recognized IBM as a leader in the file and object storage space. So the getaway chart here is just a summary of the global data platform framework. So we talked about data access services. How do you speak the language of the workloads and applications? We talked about data caching and core services, getting the right data to the right place at the right time. Data management services, visibility, control, and automation of your unstructured data, and data resiliency services, making sure you have the right security, governance, and protection in place. And that's it.